The big challenge we have now is we have this sort of, to some extent, you could argue there are conflicting criteria or aspirations. Like there's a need to decarbonize our buildings. And the best way to go towards that is often, obviously, use renewable energy as a source to supply what needs you have, but dealing with the demand in the first instance. So reducing the need for energy in the first instance. And in a way to deal with that, you end up then sort of making decisions that could be seen as counter to achieving comfort, because a controlled environment, we can achieve a controlled environment, and we can do that very well. And we've seen with technology and where we are in our science and so on today, we can create comfortable environments. The challenge is to do that in a way that's carbon neutral. And buildings, certain types of buildings are, passively cooling buildings, or using the local microclimate, getting free energy, whether it's for cooling or for heating, from the outdoor ambient and so on. They're ways that we've seen are very good for reducing our energy footprint, we'll call it. But what happens there then is we don't have the opportunity to mechanically intervene. Yeah. So you end up with this thing, it needs to be fit for purpose, but it also needs to be carbon neutral and resource efficient. So you're always just trying to reconcile those and say, we want it to be as comfortable as possible for as long as possible, but also in a way that's energy efficient. And that's where comfort becomes a challenge then.
Can't remember if we spoke about this, but I certainly had a conversation with Chandra Sarkar from Singapore about this idea that when we over-engineer spaces, we narrow the scope of expectation of those spaces, and people become uncomfortable more easily.
Which is again a bit counter,
right? Counterintuitive. That actually we're at our happiest when we feel like we have to intervene to some degree. We have agency or in control of the space in some way, and super automated, finely controlled spaces where you see it in a lot of the standards, don't you have to be within a degree of tolerance of this, that and the other. And you're going, actually, people aren't coming out the other side of that necessarily feeling any better.
I mean, it calls to mind the axiom for me, expectation is the birthplace of disappointment. So if you think about thermal expectation, right, and you're in a controlled environment and you're aware that this environment is, over-engineered, and maybe you don't use that term as a non-expert, just as an occupant, it's a sophisticated building, we can, it's very comfortable, we can control it quite well. Any research has shown, and in practice as well, that any deviation, typically in buildings that are closely controlled or have mechanical air conditioning or whatever engineering solution, that if they can control the environment very well, small deviations lead to big disappointment.
Yeah.
That people become more sensitive to those changes, that they're less willing to adapt.
And that's why I quite like this idea of these curated spaces where you can identify and curate an environment where people can find their comfort space in a building, whether that's the lighting or the acoustics or the thermal comfort, that there are different spaces that offer up a different environments that it might be late in the evening on a cold winter's night. You might want a snug, warm or warmly lit space to do your
in
work
that particular moment.
In that particular moment, but in a day, in a meeting, when you're brainstorming and everybody's on fire, you want a coldly lit space. You want it breezy and fresh airy, and you want to feel invigorated.
We're very demanding, basically.
We're very demanding, but it's not beyond our means if it's done from the ground up to curate these environments, to create these spaces. Labelling them is a different question.
It is, and it's coming back to the idea of I think, expectation, adaptation. The more aware you are, the more aware that you are of the limitations maybe of the building that you're in, the more you can work with that building and have a little bit of sympathy towards it almost to some extent. And you're right, we have different needs at different moments in time and in different types of spaces, whether we're up and moving around in a kitchen, whether we're in a bedroom sleeping, whether we're in an office, wherever you are, you do have a slightly different need in terms of your comfort expectation, those places. And the challenge for engineers and architects is, how do we deliver buildings that are fit for purpose, but are also sustainable? And that's because largely a big area is, and it's been around for many, many years, natural ventilation, or using, the untreated outdoor air as a source of both primarily ventilation for hygienic needs in the first instance, but then above that you have the need that you can say, well, we can actually use this to cool a space, maybe to heat a space to some extent, although less so. And by doing that, you're doing it in a sustainable way. but you don't have as much control over it. You're relying very much on whatever you have in the moment. So then the challenge for architects and engineers, how do we design facades, indoor spaces, buildings and so on? How do we design them to maximize their ability to have a certain robustness, or even resilience is a big thing we're looking at nowadays, that they're resilient to the changing environments and they can adapt, and stay within a range. And for buildings that don't have mechanical means of cooling, there's a lot of work has been done around this idea of an adaptive approach to comfort, that we do adapt. And it's kind of linked to the thermal history of our bodies over time, the previous week maybe, or the previous 24 hours and so on.
There's that famous picture, isn't there, of people sat outside a Parisian cafe, and it's going into winter and they've all got coats on. And then there's another picture in spring, exactly the same environmental conditions to the decimal point of temperature and humidity, and they're all sat there with jumpers on because of adaptive comfort. You come out of a period of cold, it feels warmer. You're going into a period of cold, it feels colder.
Exactly. And giving people the opportunity to adapt, basically saying, look, comfort happens at the occupant level, it happens at the human level. It doesn't happen at the building level. You experience it in a short time scale and spatially very close to your own personal experience, we'll say. And on that basis, if we can't adapt, then you're not going to be able to manage your own comfort. So there was, for many, many years, the business world or the working world, there was a sort of an approved attire, you could say, suit, shirt, pants for men. For women, they would have their own, let's say, etiquette, you could call it, right? But that etiquette didn't respect the need, that there was a need to adapt. And that's changed hugely nowadays. I mean, many people are coming to work and adapting their clothing to suit their comfort needs, because Fanger did a huge amount of work back in the 70s, I think it was, and he was one of the first people to try and, I suppose, present a formal scientific language or create a discipline around comfort and say, let's study this. What are the factors that contribute to comfort, and how can we then use those factors to achieve comfortable environments in buildings? So that's where he kind of, through chamber experiments and so on, came up with the idea that, clothing has a contribution to make here, your metabolic rate has a contribution to make here, the objective physical environment has a contribution, whether it's in surface temperatures in the building, air temperature, the speed of the air that's passing.
Yeah, evaporative cooling. Yeah, that was a big thing with conversation with Chandra in their tropical climates, is actually getting a bit of air velocity in space. Can make a huge difference.
You extend the range of acceptable conditions by doing that. Little hacks, you could call them, Yeah. So I suppose that's really, it's that idea of saying, well, in some buildings, you may choose the air conditioning for a particular reason. And their comfort is still paramount, but you have more redundancy and more capacity and more ability to absorb heat as it's generated and absorb external perturbations or, external influences. Whereas in naturally ventilated spaces are passively cooled, and there's a whole ongoing debate about the correct terminology around these things, but in those spaces, they're free-floating environments. So you have to, it's trickier as engineers and designers and architects to design buildings that are responsive to the microclimate. They can adapt well to changes and so on. And we've been doing a bit of work on something we call the cooling ladder. It's like a design ethos. And you have the approach for a designer in this ladder, a kind of a cascading effect, is you start first with sort of preventative measures. So that's the first sort of line of defense, is you try to prevent heat coming in the first place, or the incident of heat, through different measures. And we can talk about those. And then after preventative measures, the next thing would be to look at modulating measures. So now you do have some heat in your building. How can you design the building to modulate that heat? And then finally, when you've dealt with those, you have dissipation measures. So that would be your ventilative cooling. That would be using ventilation to remove the heat, so to dissipate it. And then once you've done all those and you still have a cooling problem, you're into supplementary cooling and you're into mechanical cooling. So this kind of cascading ladder, something we've been doing a bit of work on in a more qualitative way, kind of a design ethos, a kind of a principle of how you would approach design. And we're talking about cooling because when I think of comfort, you obviously have the heating season and the cooling season. Certainly in Ireland, where we do a lot of our work, it's a cool climate. We're pretty good at heating season. we're able to decarbonize our heating systems, we're able to design them reasonably well. I think we've more challenges around cooling.